All right, hello everybody. Again, this is the NASA Big Idea Challenge team with our weekly update. This week, currently we're working on getting our initial parts in. All of them that I'm aware of are now in for our starting prototype. We're still 3D printing a bunch of parts. They are taking a very long time. We've had some trouble with the 3D printer in the lab that we're still troubleshooting. And we're still assembling the test bed. The last thing to go in, which you'll see in the update, is going to be our regolith substitute. So tasks that we've finished is we have our full proof of concept circuit design done. All the CAD models are now updated. That should work properly. And our magnetic drive proof of concept has been completed and assessed.
Building off the test bed that we worked on last week, we had the frame built already. We were going to use kind of like a hard foam to create the angle in the side of it, but that came with a higher cost value than we were willing to put up with for right now. So instead, we built these stair steps that went into the corner, and we'll create about a 30-degree angle, which is the angle that we need for the NASA challenge.
The material substitute we are using to replicate the regolith is concrete sand, 1-inch rock, and really fine dust. And the dust is what's going to be the most prominent thing for these test bed.
So here's kind of just our very quick update on all of our 3D prints. We have our printed connecting rods, a total of 32 needed for the proof of concept model. These connect our eccentric drive shaft to our actual legs that are doing the moving. As you can see, this took 3 tries to figure out because with the shrinking of 3D prints, we needed to add about 0.254 millimeters, which is about 1/10 of an inch to all of the dimensions. So they'll all fit. And then we printed these with 20% infill. We haven't tested these yet. We might have to print them again with a higher infill depending on the load, but we're thinking that 20% should be fine. All of the load is compression, so we're not super worried about these tearing apart. Same with the eccentric shaft hubs. These we needed 64, 2 for each leg. Again, this took 3 tries, and we added 1/10 of an inch or 0.254 millimeters to all dimensions. This infill most likely will have to be changed if we start cranking up the robot a lot with some weight, because there's a lot of torsion inside of these, which is not very nice to 3D parts, but we'll see when we get there.
Last week we mentioned that we were 3D printing parts to connect the motors we bought to the dowels. This part took 2 tries to do, and we had to make the same adjustment as on the other 3D printed parts. We had mentioned that we had completed our proof of concept circuit. What we ended up doing is we ordered these 4 12-volt motors and 2 of the L298N H bridges, and we wired them in parallel, and we hooked them up to our Arduino. The hope for the next week is get them hooked up to the microcontroller version of the Arduino, but they're all up and running. So it's good.
An important part of our proof of concept is proving that the magnets can actually induce the kind of motion that we need for this kind of movement. And rather than taking up more valuable printing time on the 3D printers, we just threw together basically a cardboard testing stand to prove that the magnets can cause the motion. And then here we have a video of it working. We basically just hot glued and taped 2 magnets onto a dowel, and then hot glued another magnet onto the top of one of the rods, and it's a little off center. But if you were to watch the video, it'd show that we turn the dowel and it moves the foot up and down in it's down for half the rotation and then slams to up and then stays there for half the rotation and goes back down. And so we learned that we need to have maybe a little bit of damping. If we have metal parts, they'll be slammed together constantly, but it does work and it does move it in the kind of motion that we had hoped for.
So our next step is to contact Simon. They're our supplier for the Regulus substitute. We'll pick up that material hopefully next week. And then our test bed should be complete after some manual labor. As we said earlier, we were struggling with 3D printers, so we're still printing parts, and hopefully we'll have an assembled initial prototype that you guys will see next week for our update. Thank you.